Well, good morning, everyone, from here in London, and I'm really delighted to welcome you to another FS Club webinar. Today's subject is data gravity, and believe it or not, it's a subject I didn't know much about until quite recently, and I'm very impressed with some of the concepts. We have here today Bill Fenick. You've read Bill's CV. Bill's going to be presenting from Interaction, and he's going to be looking at the effect of this on global enterprises, the top 2,000 enterprises in the world. Now, you know me, Michael Mainelli. I'm one of the directors of Zien, and it really is my privilege to be able to introduce these webinars. And the reason I say it's a privilege is because our wonderful range of sponsors allows us to range widely across technology, economics, and finance. And today we're really going to be meeting at the junction of all three of those: the economics, the gravity of data, the importance of technology. Interaction as a firm which provides data centers and networking facilities to many people in many areas, but particularly in financial services. So it's going to be an interesting subject. Now, as you know, these webinars tend to be fairly terse in the sense that I'm here to get out of your way, at least early on. And what I'd like to remind you just before I disappear is that we will be taking questions which I will feed in to Bill in a discussion during the Q&A session. But to get those questions in, please do get them in early. People who send them in at about minute 44 wonder why I don't cover them. And secondly, please do use the GoToWebinar facility. That's just to type into the chat. It will come straight to me, and I will feed them in with Bill. If you email them to me, I'm afraid I'm here with you at the moment, so I'll only be picking those up too late. So with no further ado, Bill, the floor is very much yours.
Very good. Well, thank you very much. Thank you, Michael, for the invitation. I'm very pleased to be here. Once again, my name is Bill Fenick, Vice President for Enterprise for Interaction. Interaction, just as an introduction as well, Interaction was bought approximately a year ago by Digital Realty. So Interaction is a digital realty company, which is now a global player. So you'll see a lot of digital realty in here. We've been speaking a lot about data, and data has been one of our top themes for many years now. From an interaction perspective, and then more and more from the digital realty perspective, we've always looked at applications and workloads and to see what is creating data and what type of requirements do those workloads need in terms of latency, in terms of proximity to eyeballs, for example, etc. So this is a subject that's very much the heart of what we do. Michael, perhaps the next slide. Yeah, that's the, excuse me, next slide then. So that's the title. It's the Global 2000 Enterprise, which I'll be speaking about quite a bit. Not sure if we want to pause here for the poll, Michael, or if you'd like me to continue.
Yes, I think that'd be a good idea, Bill. Folks, I'm just going to be launching a poll in a second, asking you really in which geo-region will data grow the fastest over the next 3 years: Asia Pacific, Europe, the Middle East, North Africa, or North America. The poll is now launching. And while you're filling in the poll, I just thought I might point out that data gravity as a term was coined in 2010 by GE engineer Dave McCrory in a blog post looking at the way data attracts other data and services, just as a planet attracts gravity. And these large accumulations are likely to accumulate even more data. Anyway, really moving well on the poll there, folks. Almost 3/4 of you have voted. I'll close the poll in just a second and share the results. And here we go. Wow. Well, the rise and rise of age over the years is
well, I think we've got a few people here who know what they're talking about.
Good. Anyway, back to you, then.
Thank you. Well, one more slide, please. Okay. Michael just mentioned that we do have Dave, actually, who came up with the term data gravity. Dave is now a colleague of ours at Digital Realty, and as a matter of fact, he and I went through these slides a couple of days ago, so a lot of these slides are what he uses. But what we're seeing is the intersect between the cloud and the enterprises. And what's really interesting from our point of view is that we've got a front row seat on first movers. So we really can have this vantage point of seeing when a large company is going to tackle perhaps a new geographical region. I can give you a good example of that. A very large social media company starts to go into our Marseille data center. Marseille is the jumping off point for a lot of North Africa, Africa, and then the Middle East. So we can see when they start, when they actually have requirements, their business requirements, you could see and you could predict almost a year out where they're going to be, which markets they're going to be attracted to or go into. And so that's the vantage point that we have, having cloud providers, having all these enterprises. And what we started to look at is the enterprises and how they create data. Which really gives us a good feel for that. So maybe if you can show the next slide, then we looked really at the data creation cycle and what is happening and who is creating the data. So of course people are creating data. But I think more so, and this is something we know, particularly for people in the know from the financial services industry, is that machines are really the biggest processors of this data. Or the generators, perhaps, is the best way to say it. So it's machines, it's people, and then it's the interactions between and the transactions between this data. How do you take this data and start to understand what type of decisions to make on it? As an ex-Reuters, a Thomson Reuters person, many years ago we came up with this term infobesity. And infobesity was just this mass of data, and what now needs to happen is this massive data is being produced, but then the analytics, how do you curate this data to actually understand what are the right decisions to make based on the data that you curated? So we're seeing all of this interact, and it's creating, as we can see, more and more data. There's the old adage that I remember in many conferences about 10 years ago that the world has created more data in the last 5 days than the last 5,000 years aggregate, or something like that, right? I think we've all heard that. Well, that exploded. So the acceleration of data is more and more on that. So who is actually creating the data and what is happening? We see more and more that the enterprises are creating the data. Enterprises, of course, comprises financial services as well, with a multitude of financial services players and exchanges, etc. We also see that the mergers and acquisition is really a push in terms of the volumes of data here. And then, of course, the whole digitalization of this data that allows it to be brought to a level of analytics, be it machine readable, from the news, we tagging the data, coming into structured and unstructured data and making it readable, translating it into a simple language that all applications can read, etc. So it's really about the data and the physicality of the data as well. And that's what we started to drill down in further and further about where's the physicality of this data? Where can it be seen that the data is the most productive? And what are the requirements? Are there indeed a proximity requirement, a latency requirement, etc.? So in that respect, we came up with a formula. You pass to the next one. So the formula is actually what is data gravity and where is it necessary? So when I looked at this formula for the first time, which was only a few months ago now, I actually thought of my old market data days, my Thomson Reuters days, of looking at how this formula was put together. For those who are in the know from a financial services background, the data is seen, particularly an instrument of data, is seen from a data mass perspective. Data mass we would call static data. Company data, static data. So I'll give you a very good example. In the financial services industry, we use instruments, and then they're called RIC codes, or you call them license, etc. But one RIC code would be British Telecom, BT.L. A RIC code we've used many, many times here in London. BT.L is comprised of, if you subscribe to BT.L, you get the static data. The data activity then would be really the deltas, the updates. First, your bid, ask, last. And then you have to see how many times it updates per second. Some of these can easily update 500 to 1,000 times a second, based on some of the derivatives behind it, etc. And then you have to divide that by the latency. When do you need this data? Are you okay with having a 5 millisecond latency? Or are you trading it on a machine, or black box where you perhaps say 5 microseconds and then stretching out further down and perhaps even to the nanoseconds? So this whole concept really makes sense if you take it, or from my point of view, if you apply a lens of financial services. What's happening that's really interesting, though, is that this type of, if you will, low latency trading that we used to call it years ago, which of course it's still called that way, but what was really revolutionary 20 years ago and has just accelerated over the years, is now being applied across the board to all enterprises. And that's the really interesting thing, is we can take a lot of this experience and pedigree that built up over the years from financial services, and we can see it playing out in the enterprise space. And of course, the enterprise space is huge, with infinite almost number of companies out there. So it's really kind of fun to take this as a proxy. So what we started doing is we said, okay, enterprises, almost an infinite number, millions. What should we look at as a real proxy for this? And we looked at the Global 2000, and we started to see how are they doing it, because we as many people think, they're probably the most sophisticated enterprises out there. They've done phenomenal spend. As you can see what their spend looks like, from a network perspective, from an ICT perspective, and they've got employees creating data, and of course they've got applications or workloads creating data. So we really looked at the G2000 as a proxy to say, what's happening? And then we started to think about, okay, they're creating a lot of data. What's becoming more and more important is the location. Where are they going to be sitting, and who needs that data? And so we started looking more and more at location on that. But before I get into the location part, if you go to the next slide, let me just tell you a little bit of the methodology of how we built this up. So we started to build these reports around data gravity, particularly geographical locations. And that's why the first polling question about who will be producing the most data over the next few years is really interesting. And I have to commend everybody. It seems we got 80% who got it right. But we started to analyze thousands of the attributes, as you can see. And we identified the data masses. Which cities, which metros are actually trading data back and forth? And it's no surprise that large cities that have a geographical proximity to each other, data back and forth. But then we started to quantify that a bit more to say, what is that actual data? What is the actual, if you will, life cycle of it, but also perhaps round trip? I mean, we'll get back to my old latency book, round trip times, etc. So we had a look at that. If you can go to the next slide, please, Michael. We had a look at the geographical part, next slide. And we started to see, interestingly enough, where data is being created and, if you will, exchanged. And there's no surprise that from the Americas, New York is the top. Ironically enough, it's also the center of financial services for North America, if not global financial services. Secondly, we see London. London is the top, not only because of the financial services, but the proximity of the cities. If you think of the cities and where it's exchanging and trading data with other enterprises, if you will. Of course, Amsterdam, Paris, and even Dublin are close enough for that data exchange to happen in a rapid manner. And then Tokyo being, in many respects, the gateway into Asia, particularly from a financial service perspective. So we really had a look at that, and we started to drive down. And that allowed us to create what we started to see as some insights around forecasts. And to say, where is this data going to be created further and further? You can see here, 2020 looks almost meager. It almost looks meager compared to 2024, the data that's going to be created. But if you think about it, 2020 well exceeds any of the preceding years, well exceeds it by double, triple the amount. So the data is just going to absolutely explode over the next few years. And we started to look at the physical locality. Of course, where is it going to explode? We're thinking that is where we should start to direct investment on these things. And the whole notion of investment is where, a data center provider in particular, where you put your data centers. And the old adage is follow the money. So data is now, if you will, equivalent in some respects to money. so we're following simply the data to see where it is. So if you go to the next slide, please, Michael, you can have a feel for where the data is. And this was the prod for the very first poll question that Michael asked you about the fastest growing region. Now, as you can see, EMEA has, in many respects right now, a very large acceleration rate. North America is still a little bit larger, but it's in APAC where it's really going to take off. And that's where, I don't want to say the lack of sophistication. The start of it was in many respects in North America. We see that they're getting. Europe is slowly catching up, and Europe will probably overtake soon. But the explosion is going to happen actually in Asia. It won't be quite what Europe has in terms of volume, but the acceleration rate and the intensity rate will definitely be in Asia. And that's where, that's what we're looking at. We're looking at projections of cities. What cities are really going to take off on this. So if you go to the next slide, please, you can start to get a feel for what the cities are and where, where that data is going to be taking off. And what's really fun for us is to look at the cities and to understand, if you will, the coupling between the cities and from a geographical location, etc. If you can see right now, London is still the leader in the whole of the metro race at the moment. And we think it's very much due to the fact that such large metropolitan cities, the Parises, the Amsterdams, the Dublins, are in quite close physical proximity. Quite close, you can almost measure it in microseconds, not microseconds, milliseconds. A round trip time to Paris is from London to Paris and back is approximately 4 to 8 milliseconds, depending on which type of fiber you're using, etc. And perhaps even some of the low latency guys can get it under 4 milliseconds. We're noticing more and more how metros are the key to where data is being exchanged. And what happens in these metros is that more and more of communities of interest or ecosystems are created there. So if you go to the next slide, please, you can actually see the top metros. And the top metros are the exchange between London and Amsterdam. You can ask yourself why. Well, Amsterdam is actually known from many perspectives as a very large city for digital media. Lots of digital media firms have put themselves into Amsterdam. London is still this fantastic city that has this combination of not only financial but of entertainment, of technology companies, and it's just is the premier city currently in terms of the whole connectivity and the data that's being created and exchanged. And it's the real important thing is that the data is not only being created, but it's being exchanged. And so you can see where the likes of the cities are. We, though, see Asia really coming up the stack. We've got the Shanghai-Beijing exchange here. And then slowly we'll see Hong Kong and Tokyo really come into fore. As you can see, they made the top 10 down below. So it's really the whole proximity and the latency question that we looked at. How do we look at this, though? The real key is how do you actually look at it? Because we can all kind of picture London, Paris, Hong Kong, Tokyo. But what you have to do is you actually have to look at the plumbing to see how the data is exchanged. And in the plumbing perspective, you see where the submarine cables are going. And you see how data is actually being exchanged. And here's a nice picture that just shows the actual plumbing underneath and the amount of data that is exchanged. In many respects, for those old enough to remember the whole internet boom back in the late 90s, early 2000s, that was actually the forerunner for a lot of this data exchange because people were so optimistic about the internet, they started to lay all these submarine cables or subsea cables, excuse me, that's how they're called, submarine cables. And many of these companies went bust. But all the fiber sat underneath still. And this fiber is now being exploited and facilitated and, of course, enhanced continuously with more and more submarine cables being put in there. So we really look at how data is traversing, the physicality of it, and the location of it. And big leaders that will be no surprise for this data, particularly where it resides or where it's being computed, are the large cloud providers, the CSPs, cloud service providers, which we read about every day in the newspaper. The Microsofts, the AWSs, the Googles, and then a couple of the others are with the IBM, Alibaba's coming in there, etc. And this is really important to say, where is the cloud physically going? Because the cloud ultimately is a physical place. And Michael, if you don't mind, just going to the next slide. Just looking at Europe here, and this is an interaction. So this is an interaction slide that I've taken here. But you could see the amount of cloud providers that are coming and the cities that they're located. Frankfurt by far is the largest in our state. But to be fair, London is actually the largest cloud city, if you will, in all of Europe, followed by Frankfurt and Amsterdam and Paris. In data center speak, we talk often about FLAP, Frankfurt, London, Amsterdam, and Paris. And that is where the largest data center cities are. And you can imagine that's where most of the data is being exchanged. So anybody who has access to FLAP is really key to this whole creation. And you can well imagine that the cloud providers talked this many, many years ago. They started building up a whole cloud solution there. So on that. So I'm going to go into the implications now of some of this data and where we go with it. Okay? So this is where the technology starts to really play a strong part, is that you've got what we call the edge, and you've got clouds, and then you've got producers producing the data, be it IoT data, be it potentially data in a driven car. So you start to think, okay, where is the edge now? Who's actually creating the data? Where does that data need to go as an aggregation point? And that aggregation point could be where it's curated. They become an unstructured data scheme to a structured data scheme, where it's analyzed, and then where it needs to be distributed to. And this is really important, once again, that we take, so the importance for me at least, is we take this concept of data centers, financial services, and low latency trading. We realized a long time ago that if you have a matching engine from an exchange sitting in a particular location, and your trading engine is sitting further away, wherever that further away may be, it might be 5 miles, but it might be 50 miles, etc., that there's actually a disadvantage in terms of the data being transferred. And that's where latency, and if you will, low latency really came into being. And this is the methodology that we're taking that was really built up maybe 25 years ago or so, and it's just continued to evolve. But this is the methodology that we're looking at more and more today in the main. Because what's happening is that the data that is growing at such an accelerated pace that some of the old architectures that we use, be it hub and spoke, if you will, be it everybody taking their data and distributing it into multiple places, are slowly not working, not keeping up from a synchronization point of view, or potentially from a business impact point of view. And so we started to look at where should the data actually be aggregated, and that was a key theme for us. So, Michael, do we have the next poll question now? I don't want to quite give the answer. Michael, you're on mute.
Bill, yeah, just in a second. So,
okay, sorry. So I don't want to give the answer away to that. But what we're looking at more and more though is where the applications are sitting. Most can imagine the applications are slowly being migrated to the cloud. Quite a few of the applications. Applications that you can bring to the cloud, you do bring to the cloud. So it's really important, where's the cloud sit? Now, clouds usually have what they call the two aspects to them. They have a compute aspect, and they have the on-ramp aspect, or network node, if you will, or network POP, however you'd like to call it. And so where the compute sits and where the access point to the on-ramp is really important in terms of data being sent to the cloud and then data being retrieved from the cloud. So once again, we start to see the adjacency or the proximity to the cloud and becoming more and more important. And I'm speaking in this respect, once again, using the G2000 as a proxy, the large enterprises of Proxy, to say we actually need to be closer and closer to where the cloud compute sits. And that's the interesting thing. Is this methodology, once again, I keep referencing it, but this is what we understood 25 years ago in the financial services market, of where does the data sit, and where should my workloads be, or my trading applications, etc. And the confluence, if you will, of the edge devices. Edge devices can be everything. Michael mentioned earlier about my colleague Dave, who opened up or created data gravity. He was actually working at GE at the time with wind turbines. And it's very interesting to see how they use the data and how wind turbines would actually use that data to influence which way they should turn to pick up the great amount of wind, and etc. So machines making real-time decisions, needing that proximity once again and the latency. So what we've seen is the onset of a lot of the cloud providers and then the enterprises taking advantage of the cloud. And a big way they take advantage of it in the very first instance is what we call rewiring the networks. They decide, where should my networks be? And what is the most advantageous to my networks vis-a-vis the users? And so you can see here all of the characteristics that we take in around, once again, the creation of data, the distribution of data, and who actually needs it. And so we play around with this quite a bit in this respect.
Good.
Go on to the next slide then.
All right. Well, we now have a poll for folks, so just give me a split second here to kind of just rack that up.
Yes. So I think I tipped the answer here, but let's see.
Yeah, we don't want to give it away too early. So the question is very much what is or will be more prevalent regarding data. Will be the data will be shipped to the workloads, i.e., compute, or the workloads, the computation will move to the data. So answers on your buzzers, please. Over half of you have voted. I'll leave it open just a little bit longer. Okay, we're now up to 3/4 of the audience voting, just about to close it. Okay, and I'll now share the results. And I think, Bill, you've got an extremely shrewd audience out here.
You know what? They're very good listeners, so I think I tipped my hat on that one. But Michael,
okay.
Let's go back to the last slide, though, that I didn't realize were already questions. No, the very last one. There we go. Just on the last point, though, is that something that a lot of us clocked a long time ago was these clusters. And what we called a cluster was a community of interest, and have multiple providers, be it cloud, be it independent software vendors, be it users, all sitting in one place, so they're a cross-connected way. And I think a nice example of that might be the cities, how cities have little clusters of people, or as I used to tell my parents or my wife, what a data center really is a really nice shopping center. Where if you go to a shopping center here in London, you want to go to see John Lewis, and you pop around to tons of other little shops in the shopping center, or how an old city downtown used to look. That's really what a data center is. And so a data center, in many respects, looks like a very modern technology shopping center. Anyways, so that's the presentation, Michael. I don't know if you want to open it up for questions or.
Well, great. We've got a lot of questions, Bill. It is a very interesting concept for the audience, I can tell. I'm going to open up with two, actually, that came in pretty much together. From Hugh Purser, junk DNA. is a familiar phrase in biological sciences, although it may be a bit less junk than was first thought. Is a lot of data actually junk? And Professor Ian Angel has a related question. Do you have any figures for the information to noise ratio in the data?
Yeah, those are really good questions. Really good questions. So I'm going to lean back a little bit on what's in my financial services pedigree. I remember years ago, the update rate, which we thought was phenomenal back then, of market data was well over 1 million updates per second. And it's just accelerated. I don't have the very minutes. But what was interesting, what we used to do a lot of analysis on was the update rate of the data and the actual trade data. And what we started to see was that there's a lot of white noise out there. So I think one of the questions was, there's a lot of noise. And I think that's absolutely the case. There's a lot of noise out there. And that's why the importance of not just the creation of data, of course. The data is fantastic. You have to be able to do something with that data. And that's why the importance of curating that data, unstructured and structured data, and bringing it down to a common language, taking that and analyzing it and allowing either a machine or a human being to make an intelligent decision on it is really the big case. And I think that's the hardest nut to crack still. There are multiple examples of that, even among government institutions who don't talk to each other. So one institution has the data, but it's actually much more relevant for another government institution, but somehow the data is not being transferred. So, to answer your question, yes, we do have a lot more data. And we drill down in it in terms of do we have that? And what I would say is, please drop me an email. Take it offline, but we have a lot of data that we're happy to show you in terms of some of the transfer. But I think the biggest nut still to crack is the white noise, if you will.
Okay. Got an interesting point here from David Pugsley. Will AWS capture most workloads due to their company?
It's a really good point. So I think for those who are in the know from the cloud, AWS is well ahead. Microsoft is playing a fantastic game of catch up, and Google is a bit of a distant third. What we look at, particularly from a data center, physical data center infrastructure player, is what workloads will go to the cloud. And we can say right now, particularly from our experience, from an enterprise perspective, is that workloads that can go to the cloud indeed will go to the cloud, unless they're proprietary, meaning proprietary workloads where they have a challenge around perhaps the proprietary data sitting in it, that they don't want that out there, or indeed that they're legacy systems that are just running beautifully. You don't know what to do with it, and the people who maintain and code these systems, retired 20 years ago, right? So a lot of legacy applications and proprietary applications won't sit in the cloud. There are other dynamics around. So, for example, artificial intelligence. Some of the appliances that you see, some of the large vendors, NVIDIA comes to mind. Sometimes they sit better not in the cloud than in the cloud. But AWS will capture its lion's share. There's no doubt about that. Let's see if Microsoft's going to catch up. Microsoft, they say, has a much stronger enterprise play because Microsoft has been involved in the enterprise for a good 30 years now, with the Office suite and Windows 2000, etc. All the platforms that they started to introduce 30 years ago to the market. However, AWS is the leader at the moment, and let's see if they're going to catch up.
Bob McDowell has some geopolitical implications here. He says, I can envisage serious levels of metro connection within countries in Asia Pacific, but I doubt the scale of cross-border in Asia Pacific compared with North America and Europe. And he therefore wonders, is data gravity a force to combat global fragmentation?
Is it a force to combat global fragmentation? That's a good one. I don't know if I have a quick one-line quip on that. That's also a good discussion for a whole dinner. But it's really a good one. I have to think about that for a moment because we see the amount of artificial intelligence being used today, particularly in the likes of China, with facial recognition. You can almost pay, or you can pay with your face these days. Right? That's data being created and identified. And have some pushback of people who have, privacy concerns, identity concerns, etc. In terms of whether come back with fragmentation, that's a good question. I'd have to think about that one. I don't have quick to say on that one.
Michael Cooper is curious. How do you think trends like distributed architectures, data localization, and the like impact this? And to what degree is what you are seeing just correlated with the current infrastructure sophistication and deployment?
Well, it's definitely the current infrastructure and sophistication deployment. There's no doubt about it. But we do see an acceleration. And we can see that mainly via the situation that a lot of us are in today with the pandemic and the acceleration of a lot of different technologies that we kind of took for granted. We're not getting dusty, but they were not used to the fullest hilt, and all of a sudden we've broken through. We've crossed that Rubicon, and now everybody's using these types of technologies. So I think it's very much based on current infrastructure, but I'm sure that new ideas will be created all the time, and we can't even foresee what's going to be happening in the next 2 years because things are moving so quickly, and a lot of barriers have been broken down, perhaps due to the fact that we're all having to sit at home working. So I think just some practical things are going to create a lot of new ideas.
You touched on this briefly, but I think Ian Sheridan would like a little bit of expansion. Machine learning analytics is a growth area.
Yes.
Obviously, there are a lot of implications between the scale of data required for that and the workload.
Absolutely.
Does that create opportunities for cloud businesses in areas with AI talent? For example, Silicon Valley, Cambridge, England, and Edinburgh.
Absolutely. I mean, I think, it's interesting. Cambridge was put in there. Most of us know that ARM is based in Cambridge, the headquarters is based in Cambridge, and then there's been an acquisition, or not an acquisition, an offer for ARM from NVIDIA, which is, of course, one of the leading AI machine learning companies today. But whether they'll go through or not, we'll still yet to be seen. But what happens is that machine learning or artificial intelligence needs an enormous amount of data, and these are called data lakes. And so data lakes or data storage data lakes can be put either in the cloud, of course, using storage capability computation of the cloud providers, or they can be built up with other vendors, the HPEs of the world and what have you. So you can put your own private data. But machine learning and artificial intelligence lives off of data, and it is volumes upon volumes of data. And that's how the machine actually understands the patterns. So, they're definitely, these are definitely reasons to be this business, is that more and more data will be created and utilized by this.
Okay. Back to Ian Angel. I've got a few more questions, but Ian is curious about what you've done in terms of analyzing the categories of data. And do these categories of data impact your data gravity measurement? Because data is not homogeneous. How much detail have you gotten into there? And any thoughts you have on, do you perceive some serious security issues?
Let's take the first one. So I think a lot of it's based on bandwidth and the utilization of the bandwidth. So there are multiple categories of data, of course, but a lot of it's based on bandwidth utilization. But we can dig into that further. And then security issues. I think security is always an issue. It seems once we barricade one hole, another one pops up. But we all know that the cloud providers are getting much better. So they used to be the biggest concern for most enterprise users or any user about security. That concern seems to have lessened or diminished. Not 100%, of course. But security is always an issue. And that's why I was also mentioning a lot of proprietary applications that have proprietary data sitting in them. Many enterprise compliance firms still do not want that data sitting on the cloud. Of course, there's also residency issues as well, but one shouldn't forget about residency issues. GDPR and data residency, data sovereignty. The likes of Switzerland, do not want to have data traversing into the likes of Dublin, perhaps, or data residency and data sovereignty is a huge thing. That's not to do as much with security, in the first instance, but it definitely has a flavor of security.
Yeah, I'm going to squeeze two in, but we'll have to be quick. Mark Cook wonders, does Bill have a view on the mainframe as a hybrid cloud server as the data can be worked at source, for example, AI and machine learning again?
Mm-hmm. So mainframe, when I thought of mainframe, I thought of IBMs, but maybe I'm not sure if he's thinking mainframe being appliances. But we are seeing some mainframes being moved into co-location, adjacency to the cloud. But I think the mainframe was something of what I was referring to, where the developers, the people who maintain them, to some degree, all retired 15 years ago, and these things are workhorses. They're still the main some of the main infrastructure within a lot of these corporations and enterprises. So,
Yeah. Well, Mark's a bit biased, but he does point out there is an IBM Z platform that runs Java. But anyway,
I'm sure there is.
Moving this to a little bit of a close here. There are many other interesting points. So Ian Angel, again, is very interested in regulation and taxation raising its ugly head.
Yes.
Hugh Perkiner asks, are there implications from Brexit that could impact London's data gravity within Europe? I'll be getting all those questions over to you, and you can answer people directly yourself later. But I kind of wrap it up that there is an interesting point here that people are making. Is it the case that some of those numbers you showed, particularly with Amsterdam, does that show that the implications from Brexit are affecting London's data gravity within Europe?
I guess we're going to know this in 4 weeks' time, aren't we? But I'm hoping it's not going to be the case. It's a really difficult one to figure out what's going to happen with Brexit. What I was speaking to an exchange just 2 days ago, as a matter of fact, and that exchange has built, it has a regulatory corporation now in Paris. But I asked the person specifically, who's the CTO, I said, what about your actual physical infrastructure? So no, that all stays in London. So that gives me hope, particularly somebody who's lived in London the last 25 years. That definitely gives me hope. Whether hope outweighs reality, I don't know. We'll have to see. But I think the infrastructure physically will stay in London for the time being. Potentially data will have to be stored in another place, depending on what GDPR data type of agreements are finally settled with the whole Brexit story.
Yeah. Well, I hope so too, because I live just south of Brick Lane, and I've had the privilege of touring your facilities there, which are darn impressive, actually. Anyway, sadly, as ever, time comes to all people. I'm getting lots of nice comments in about the talk. All of this will be sent to Bill, folks, and I really do appreciate you mentioning that. Apologies that the sound quality was a little bit poorer today than usual, but hopefully in this hybrid cloud, things will improve remarkably. I've got 3 things to do here by way of thanks. My first round of thanks clearly goes to our sponsors. Many of you out there, and you're very, very kind to let us wander across subjects that we just find interesting, and I'm sure that you found them interesting too. Bill does have a report on this, as well as the slides that are up on the site. You'll find equally that the report can be downloaded, and there's a link on our site over to the Interaction report. Secondly, I'd just like to point out to the audience, thank you. Without all these great questions coming in, it would be a very quiet 15 minutes. Well, if you believe that, you'll believe a few things. But we will be touching on Monday again on data localization, but more from a legal perspective, looking at Schrems 2 and cross-border data compliance. And next week, a big focus on Dubai, which is going to be interesting because Dubai has been rising more rapidly than most centers in our indices over the years, although a little volatility there. And we'll be looking at the systematic effects of the long-term on technologies with Dionysus Demetis as well. So lots coming up. And finally, I'm currently reading this book, which I wanted to, Apocalypse Never. And we're going to have, why environmental alarmism hurts us all. So lots of things happening. And as ever, go to the website. But finally, I'm afraid, Bill, I'm unable in this age of sitting at home technology to open the floodgates for applause. But on behalf of the audience, I have my little applause-o-meter here. It's a It's my Korean karmic clapper from a temple in Bulgoksa, Korea, and I wish to thank you very much. It was a really good session, and we hope to have you back because this is truly a fascinating concept for all of us who are working in finance.
Hi, I'd welcome the opportunity. Thanks, Michael.